Hi, I'm an old guy and I do maths. Today we're going to look at nuclear decay and how we go about finding a half-life for an isotope. I've done a previous video on finding K, which is the constant of the isotope, and we're going to do that again today rather quickly, and then we're going to get into how we go about finding a half-life. So there are a couple of things that you need to know. To start out with, if you haven't watched the previous video, this is the formula for nuclear decay. This is the mass that you wind up with. This is the original mass of the isotope. This is time, T is time, and K is a constant for that isotope. Each isotope has a constant. I make up isotopes as I go. This is not a physics or a chemistry channel. This is mathematics. So, and especially with this one, people who do physics or do chemistry will see that I certainly have made this up, and they may even be able to guess the answer. But we'll come to that. Okay, so how do we calculate a half-life? Well, it's the initial mass times 2 to the power of negative kT, and we make that equal to a half of the original mass of the substance, and what we get here is the amount of time that it took. Basically we're solving for this, we're solving for T. Initially we might have to solve for K, and I'll explain why when we look at the problem. So actually we probably better look at the problem. Let's have a look at this. Now, a substance decays to 1/8 of its original mass in 2,500 years. The physicists and the chemists may have guessed the answer to this already. I chose this very deliberately, and you'll see why in a moment. Okay, so it decays to 1/8 of its original mass in 2,500 years. We're to find its half-life. Now, normally this would be written as a percentage, I guess. I've chosen to write it as a fraction to aid the mental arithmetic of the physicists and chemists who watch this. Okay, well, let's put some numbers in. So 0.0125, which is 1/8 of the initial mass of the substance, is equal to the mass of the substance times 2 to the power of negative 2,500, which is T in this formula, T. We need to find K. We don't have K. We don't have the constant for this isotope, which is a made-up isotope, by the way. So we're just going to solve quickly for that. If you want a more thorough explanation of how to solve for that, there's a video in this playlist on finding K. Right. So we use logs. We'll just take the log of this. Basically what we do is we rewrite an exponential equation as a log equation. So log 2.125 equals negative 2,500 K. We can rewrite this as K equals negative 3 over 2,500. Why can we do that? Because log 2 of 0.125 happens to be negative 3. You can pop that in a calculator and check that. So basically this is that value there. And when you divide negative 3 by negative 2,500, you get this number, 0.0012. As I said, I'm running through this reasonably swiftly because there is another video the playlist on how to do this, and you can pop that into your calculator, and you will see that it is indeed negative 3. Okay, so what we've got here is we've got K. We've found K. So we have that. Now we can go after this. Right, so let's do that. The formula for the half-life of a substance is, as stated previously, it's here, and we are looking for that. So let's put our numbers in. Well, there's not a lot to say to start with, because the first thing that we need to do is we need to get rid of these. We can divide each side by AO, which gives us 2 to the negative KT equals a half. And away we go. So negative KT is now equal to, if we rewrite this as a log, negative KT is equal to log in base 2 of a half. Now, a little sidebar here. Log in base 2 of a half is negative 1, because 2 to the power of negative 1 equals a half. So this thing here, whenever you're dealing with a half-life and you're using logs, you can always take this shortcut. The log of this is equal to negative 1. So basically, if you were familiar with this, what you could do is you could just go from here to negative KT is equal to negative 1. Anyway, we've done the steps. So negative KT is equal to negative 1. We can rearrange this to the following. T is equal to 1 over K, which is 1 over 0.0012, which is 833.13 years. Now, I wonder if anyone guessed this. And the reason I wonder is because if we conceptualize a half-life, if we start with a substance that is 1, it moves to a half, to a quarter, and to an eighth. And it has been through 3 half-life periods to get there. Now, we started with 2,500, and if you divide that by 3, which is why I was wondering if people would spot this, if you divide that by 3, you get 833 and 1/3, which is, I guess, a good check. This is why I used an imaginary substance, so that I could do this. It's not going to work every time. Well, I don't know. Maybe it will, but it won't be so conveniently packaged. Put it that way. I hope that you found this informative and useful, and that I removed some of the confusion that surrounds this topic. Anyway, thank you very much for watching, and I'll see you next time.